Hi, everyone. It's been 2 weeks since our previous online event, and I'm super excited to welcome you at Lemon.io Talks, which is a series of events for the development community to talk about the topics that are interesting for you, to connect you with the top CTOs so you can connect together and learn from each other. Today, we have a special guest with us. It's Kartick Vaddadi. After graduating Indian Institute of Technology as a Master of Technology in Computer Science, Kartik has worked for Google. Then he ran his own startup, Futurecam. Then he worked as a CTO. And now, combining all of that experience, he's working as a CTO-level consultant for other companies, helping them generate $1 million value as an outcome. My name is Kate. I'm a head of sales at Lemon.io. And I have to be honest, I'm somewhat jealous because I wish we had the same discussion as today, but for the sales team. I'll explain why. Because today we are going to talk about the real-time developing, which is like the work you do to build a code that would work consistently and would produce predictable outcomes. Let us see if we have Kartik with us. Lovely. Kartik, tell us what you prepared for us today.
Hey guys, hope you're all doing good and hope all of you are safe. I've prepared some material about real-time programming. This will be helpful if you ever decide to do real-time programming. If not, it will still make you a better engineer. So either way, this is interesting to learn about.
Oh, well, thank you so much. That was a cool intro. I'll step aside. I'll be with you on this call today, but mainly listening. It's time for you, Kartik, to share your knowledge with the rest of the team. But from my side, whoever watches this in the real time, I encourage you to add your comments, ask the questions whenever you have them. At the end of the session, we're going to choose the best question or the most interesting one, and the winner is going to win something from Lemon.io company.
Do you guys see my screen? Kate, is my screen visible?
Yes, it is.
Great.
We can see you, we can hear you.
Awesome. Let me just start my presentation then.
Sure.
So what are we going to cover today? First, we'll start by defining what is real-time programming. We'll see why it is hard and how doing it will make you a better engineer. Who am I? Kate already introduced me, so I'll skip this. To begin with, let's understand what's real-time programming. When we say real-time, we think fast, right? Imagine two browsers. Browser A loads every page in 4 seconds. B loads a page in 0.0001 seconds, except once in a month when it takes 60 seconds. Which browser would you use? Why don't you leave a comment in the comment box? Let's see what people prefer. So A always takes 4 seconds. B is usually very fast. Abbas, we are not talking about Chrome and Edge, we are talking about A and B. A, interesting. Does anyone else have an opinion? B. Yeah, I would use B because how many pages do we load in a second? Sorry, in a month? Thousands? I want all of them to be fast. If one of them is slow, I can handle it, right? So I would prefer B. Now imagine two nuclear reactor control systems. A responds every time in 4 seconds. And let's assume it's enough to control the reactor. System B responds in 0.001 seconds, except once in a month when it takes 60 seconds. Which one would you use? To repeat, 4 seconds is enough to control the reactor. So would you use system A or B? Can we get some comments? A, right? So real-time programs are predictable. They are not necessarily fast. And guys, if you can't understand my accent, feel free to let me know. Type a comment. I'll speak more clearly. And if you don't understand at any point, interrupt me because you won't be able to understand the subsequent parts of the talk. And if you didn't understand it, probably others didn't as well. And I need to explain more clearly. So don't hesitate to speak up. So system B is fast most of the time. System A is predictable. So real time means it's predictable. It's not fast. It doesn't need to be fast. And we are worried about the worst case performance, not the average performance. Here, the average performance is very fast. It's 0.1 milliseconds. But the worst case performance is 1 minute. Whereas here, the worst case performance is 4 seconds. So usually in life, say for a browser, we care about the average performance. Once in a while, if your browser takes a long time, it's okay, once in a month. But when we are talking about a real-time program, we care about the worst case performance. So it's predictable, not fast, and worst case performance, not average. And yes, Abbas and Mahesh agree with you here. And performance is part of correctness. Imagine you're supposed to get a cashback on your credit card and you get it few hours late. That's okay, right? But not when it comes to the nuclear reactor. If you react after it has melted down, it's too late, right? So giving the right answer too late is as bad as giving the wrong answer. That's what a real-time program is. Let me show you my startup's website, Futurecam. It does a lot of image processing. Like you see this light trail video in the center of the screen. This is captured many times a second, as much as 30 times a second. Now, if you're slow occasionally, the movement will not be smooth. So if you look at the top, the metro over here is moving smoothly. That's because the app is able to capture it smoothly. If there was a hiccup, it would abruptly pause in the middle and then jerk forward. You don't want that. So in Futurecam or any video capture app, Non-real-time means a video that is jerky. Okay, now that we understand what real-time is, how do we do real-time? What are some techniques? The first technique is multi-threading. It's a must. Using a single thread with async await or promises or callbacks isn't good enough. Like the typical JavaScript approach. Doesn't work for real-time. Real-time work must continue even when other threads are busy. That is why you need multiple threads. You can't multiplex things into a single thread with async APIs. And you also want to take advantage of multiple cores. Again, that's why you need multiple threads. In mobile apps, the UI thread, also called the main thread, is supposed to be the highest priority. It's supposed to be responsive all the time and not block for any other thread. Other threads can block for the UI thread. So that's how most mobile apps are built. But Futurecam, even though it's a mobile app for the iPhone, we invert this. The real-time thread cannot block for anything else. The UI thread can block for the real-time thread. So if you're recording a video, you won't be interacting with the app while it is recording, right? So even if the UI thread is blocked for a fraction of a second, it's not a problem. And to address your question, I'm not saying Node.js is not good. I'm saying for real-time programming, it may not be the best. For 90% of apps, it's great. So the real-time thread should really be a real-time thread. It should not block for any other thread. If it does, it's no longer real-time, right? The whole reason you have a separate thread, you create a new thread and call it a real-time thread, is that it's always runnable. Real-time requires you to write non-portable code like native iOS, not React Native or Flutter, because every layer in your system hurts performance. So React Native and Flutter are implemented on top of iOS. You don't want that. You want to work directly with iOS. Similarly, Apple offers its image processing framework called Core Image. You should use that, not OpenCV, which is open source and cross-platform. Because OpenCV, I'm told, is 3 times slower than Core Image. In Futurecam, we process 1 GB of data every second on the iPhone. For that level of performance, you have to write non-portable code. When it comes to memory, you use fixed size buffers. So for example, in Futurecam, we use 7 buffers for certain algorithms. That way we can calculate the size. If there are 7 buffers, each is 12 megapixels, and each pixel is 4 bytes, it's 400 MB. You do not do dynamic allocation, especially in an unbounded manner. In the very first prototype version of Futurecam, I allocated a buffer for each incoming frame, but that allocated a GB of data every second, and the phone ran out of memory and the app crashed in a second or two, right? Because if you're processing 1 GB of data every second, if you're capturing video at 30 frames per second, and each of the frames is 12 megapixels, and each of the pixel has 4 bytes, then you're processing 1 GB or 900 MB, whatever, 960 MB, whatever it works out to be per second. And if you just keep allocating memory, you can't allocate gigabytes. So that's why you have to have fixed size buffers. Another technique you use in real-time programming is to split an algorithm into 2. So let's say you have this algorithm that takes a certain amount of time. The x-axis represents time. More the width, longer the time. Right? So let's say this takes a certain amount of time, and it's a real-time algorithm. One technique we used in Futurecam is to split this algorithm into 2. First, you run a real-time algorithm, then you run a non-real-time algorithm. So instead of one big algorithm, which is real-time, you have split it into 2 parts. The first part being real-time, the second part being non-real-time. Now, when you move some of the functionality from here to here, and you make it non-real-time, it's much easier to get it to work. Because real-time programming can take at least a quarter, more depending on your complexity. So real-time code, every line of real-time code takes much more effort. So if you do this, for the user, it's not as good because it'll take more time to execute. If this were 10 seconds, you split it into a 5-second part and a 10-second part, let's say. So now you're at 15 seconds. And even visually, you can see this is longer than this. So the app has become slower for the user, but it's faster for us developers to build because the real-time part, which is very tricky and needs to be optimized like anything, has become smaller. So this is a technique that is worth considering. And the other meta point is you may need to trade off UX. Some of us want to build the best apps. We have high standards. That's good. But sometimes high standards can lead to months or quarters of extra work. So the question is, do you want it to be fast for the user and launch next year, or do you want to launch sooner? Encapsulation is important. It's always important in programming, as we all know. It's all the more so for complex problems. Real-time programs are usually tackling a complex problem, right? We are not building a to-do list app. So there's complexity in the problem domain. In other words, the problem you have set out to solve is a complex problem to begin with. Then, when you apply real-time techniques, the solution becomes more complex. So there's complexity in the problem domain, there's complexity in the solution domain. And too much complexity, we humans have very limited ability to handle this. So we need to encapsulate it. Otherwise, we won't be able to keep it all in mind. We won't be able to keep track of it. So encapsulation is a critical tool for real time. Another technique is to open up black boxes. Typically, when we program, we treat OS abstractions as black boxes. If you are building a Node.js app, to go back to the previous example, you treat Node.js as a black box. That doesn't work for real time. The complexity leaks. You should read Joel Spolsky's The Law of Leaky Abstractions, which is linked from here. We'll share the slides later. That's a very insightful article that says that complexity is never 100% contained. And in real-time programming, you have to open up the black boxes. You can't say it works somehow. You have to form a mental model, even if it is closed source, as iOS is, which is hard. You read the documentation, you watch Apple's WWDC talks, you read Stack Overflow answers. 99 out of 100 will not be helpful, but one will save you months of work. You also do experiments. You form a hypothesis. This is how it works. And you test it out. And then if it works that way, like you'll say, if it works this way, when I do this experiment, I'll get this result. And you see if you got that result. If not, your hypothesis is wrong. So you're like a scientist. You're forming a hypothesis, then you're doing an experiment, then you're validating or disproving your hypothesis. That is how you open up a closed source black box. Experience is the main thing. If someone else is to build Futurecam today, it will take them at least a year, unless they have all the knowledge I learned the hard way by doing this. Another technique to use is pre-warming. All of our computations run on the GPU, and in the very first prototype version, we invoked the GPU when we needed it. So it's a camera app, right? You take photos and videos using the app. It's not an editing app like Photoshop. Now, in the very first version, when the user pressed the shutter button, that is when we would invoke the GPU to start processing. But the thing is, OpenGL shaders, which is the way you use the GPU, are compiled on demand. So there's a C++ compiler that runs at runtime. And all that slows things down. So the result was, when you press the shutter button to start recording, there would be a lag. And then it would start recording. And in the first part, it would drop frames. So the solution to that was pre-warming, which is when the user opens the app, even before he presses the shutter button, we would run our algorithms on the GPU, do all the image processing, and throw away the result. That way, the C++ compilation finished, whatever caches need to be allocated were allocated, all that happened. So pre-warming is a technique you need to use. Keep everything warm before the time you need it. Everyone clear? Anything not clear, feel free to post comments. I am keeping an eye on it. Another technique is pre-computing, which is in Futurecam, we capture photos before the user presses the shutter button. And when he presses the shutter button, we take the last photo and save it to the photo gallery. So we are cheating, right? We are pre-computing. Slightly different from pre-warming. In pre-warming, we are throwing it away. We are running the algorithms and throwing away the result. In pre-computing, we are keeping the result. And when the user presses the shutter button, we take the last photo and give it to the user and say, hey, here's your photo. And he thinks it's super fast. This is a technique called zero shutter lag. The other thing is we need to use only linear algorithms in real-time programs. Because, like I said, we are processing 1 GB of data every second. We can't afford to process each byte multiple times by using an inefficient algorithm. So most of the time, we are building CRUD apps, and time complexity doesn't really matter, right? Even at Google, I used to use time complexity once in 3 years, perhaps. So time complexity is really overrated for 90% of development, except for real time, where it is a critical tool. So I first came up with a quadratic, which is order of n square algorithm. That didn't work, right? And actually, even before I implemented it, I analyzed it, and I realized it's order of n square. And then I made it linear. The other thing is time complexity wise, order of n and order of 2n are the same, but the latter can be twice as slow. Here you are processing each byte once. Here you are processing each byte twice. You can't afford to do that. So process each piece of data only once. You use hardware acceleration. The core image processing algorithms run on the GPU. We tried using the vector units of the CPU, which are SIMD, where you have a vector. Let's say you have two vectors and you add them, and it generates an output vector, where the 0th element is the sum of the 0th elements of the two input vectors. The first element is the sum of the first element of the two input vectors. So position-wise sum. That turned out to be half or 1/3 the performance of the GPU. So the other lesson here is real-time programming requires a lot of experimentation. It's not like there's a straight path and you just walk the path. You experiment a lot. Videos are stored in a format called HEVC, for which the iPhone has a hardware accelerated encoder. Similarly, to play, the iPhone has a hardware accelerated video decoder. So there are two different video formats, HEVC and the older H.264. The iPhone has hardware accelerated encoders and decoders for both these formats. Similarly, for photos, the iPhone uses a format called HEIC, HEIC. Again, it has a hardware accelerated encoder for that. So everything should be hardware accelerated, the processing as well as the compression and saving. You need to hook into the OS at the right layer. So, OSs offer APIs in different layers, low level to high level. It's a layer cake. You have to pick the right level. If you pick too high, they'll prevent you from building the functionality you want because it'll be too abstracted. It'll be too constraining for you. If you pick too low, you'll have to do more work that the OS already does. And your code will typically be less performant than the OS code. So you'll do more work for worse performance if you pick too low a layer. For example, for camera capture, iOS offers two layers of APIs. The higher one is the UI image picker controller. So if you're using Twitter on the iPhone and you take a photo and post it there, it'll use this API. The lower level API gives you hardware access to the camera. You can configure the settings and get the raw and compressed data and do a whole bunch of things. So we use the lower layer, which is shown in green here, to indicate that this is the one we picked for camera capture. Red means we didn't, or pink means we didn't pick it. Moving on to video capture, there are two APIs. Movie file output is a higher level one. In this, iOS saves your video to an MP4 file on the disk for you. The lower level one is called video data output, where it gives you each buffer as it is captured, and you can do whatever you want. iOS doesn't save the data to a file here. It gives it to you and says, okay, now you do what you want. We use this. And then we run our image processing algorithms and save it to the file. If we use this, it would get directly saved to the file and there would be no opportunity for us to run our algorithms. For video encoding, there are 3 layers of APIs. The highest is called AV Asset Export Session. The middle one is called AV Asset Writer. The even lower one is called Video Toolbox. So Video Toolbox lets you control frame by frame compression and decompression, which we don't need. So we use the middle level one. Again, this is too limited for our use. So we use the middle one, Asset Writer. Moving on from the technical part to the non-technical part, what do non-technical stakeholders need to understand? If you are a manager or a product manager, or a different kind of stakeholder, like a marketer in a startup that's building a real-time algorithm, what do you need to understand? What are the non-technical implications of a real-time system, of building a real-time system? First, you need great engineers. Anyone can build a CRUD app, but only great engineers can do real-time. So if your startup is into real-time, hire appropriately. It can take a long time to find really good engineers. You may have to pay them a lot, right? There would be trade-offs, but you need it. This is when the mythical 10x engineer or real 10x engineer shines. Timelines are both long and unpredictable. Add at least 1 quarter to your estimate for a real-time app as compared to a non-real-time app. If you're just starting out in a new domain, if you want to build Futurecam or some other real-time algorithm, say you're building the algorithm that transmits data from the Mars probe back to Earth, that's probably real-time, right? You can't say, okay, it didn't work, I'll try sending it tomorrow. So if you're starting out in a new domain, you need to add 1 year or more to your timeline. Sometimes we have pointy head bosses who demand, why isn't it done on time? Right? That doesn't work. It's not just long, it's unpredictable. It's not like I can tell you it's going to be 2024 October. No, it's unpredictable. Never underestimate real time. Be flexible about UX. Be willing to dial down the UX from 10 to 7 to move faster. Don't be a perfectionist. Some of us, we want to do really good work, right? We take pride in our work. We take it personally. But unfortunately, that can result in a long delay to ship. So you should explore trade-offs, like instead of building 10 out of 10, which will take a year, should we build 7 out of 10, which will take 6 months? Be flexible about scope. Sometimes what happens, these conversations happen in a top-down manner. Business people tell us engineers, this is what you have to do. And we don't get to change the scope much. But with real time, it can't be that way. It needs to be give and take, not top-down. So if the engineers say, why don't we target only new iPhones? Management should be willing to consider it seriously. They can't dismiss it by saying, no, we can't because many people are using an older iPhone, right? They have to understand the trade-offs, unless they want a delayed launch. So in order to launch on time, we need to be flexible about scope. Avoid real-time if you can. See if you can reimagine your app to not be real-time. For example, Futurecam is a camera app. It processes photos. It captures photos and videos. So the way we are doing it is we are processing video as it's captured. Instead, could we build an editing app where you already take a photo or a video and then you process it? Think of it like Photoshop or Adobe Premiere Pro. That is not real time, because while editing, if it hangs for a fraction of a second, it's okay. If it hangs for 40 milliseconds and you are capturing video at 30 frames a second, you have dropped a frame, because every 33 milliseconds you're getting a new frame. So if you hang for 40 milliseconds, you have dropped a frame. With editing, it's not so kind of problematic. The constraints are not so tight. Now, this again you should be willing to do at the cost of UX. So that's the material I have prepared. Do we have any questions, comments? Or did I put everyone to sleep? We'll also give a gift for the person who asks the best question. Do we have any takers? While people ask a question, I'll just show you Futurecam. We have a liquid shutter where you can take a photo and adjust its exposure to make it more milky or less milky. So imagine a different situation, right? Say you're photographing the sunset and this is the sea. With an SLR, you have to choose the setting you want. And if it doesn't produce the result you're hoping for, you need to retake the photo. By the time you do it a couple of times, the sun will have set and you have lost the opportunity. With Futurecam, you can capture and then change the exposure using the liquid shutter. And this is a creative choice. Different people can prefer different photos. Maybe you like this and maybe I like this, right? So it's a creative tool. It doesn't force everyone to take the same kind of photos. We have light trail videos, which we saw. You can control the light to create this silhouette with light painting. These things are from a second mobile phone. We have a time lapse, which is a speeded up video. We can capture a burst at 30 frames a second. Notice how each position of the pigeon's wing is captured. Unlike Apple's camera app, which can capture only 10 frames a second. And this is actually slowed down so that you can see it. Otherwise, it's so fast you won't be able to see each frame. Like on the website, we have slowed it down to illustrate it to you. We have a computational zoom. This is the iPhone. This is Futurecam. This is captured from the 7th floor down to the ground floor. Again, using a phone. We can brighten dark scenes. This is the iPhone. This is Futurecam. Notice the contrast from the jet and 3 stars. And some fainter ones here. Futurecam can capture with more detail without the noise. This is the iPhone. This is Futurecam. We can remove crowds. So let's say this guy in the blue is your friend and you're photographing him in front of a public place. Because it's a public place, people are coming in the way. I have come in the middle here and there's another guy in the background who are interrupting the photo. They're photobombing. Futurecam will detect and remove the crowds. So you're left with just your friend. So anyway, these are all the features of Futurecam. And that's what I wanted to share with you. Do you guys have any questions? Abbas, I agree. I should have maybe showed this earlier so that, you understand the context. Yes. So now you can connect the technology to the result. In order to build all of this, you need real time and high performance and all the programming techniques I pointed out.
Lovely, Kartick. Thank you a lot for the presentation. I think more questions will follow right now. We had a question. In which case we do not need real-time programming, and and I was also wondering, because many of our listeners, they are engineers, but some of them would love to potentially switch to the CTO role. So that's right, when you also have to take care of the team, the business processes, the business model and everything. So I was wondering, Are there any objections from the development teams to use real-time programming?
Typically, there wouldn't be an objection as such. Typically, the problems are faced not by the engineers, but by management, such as long timelines, unpredictability, needing to hire more people, needing to hire the top quality engineers, which again affects the budget. So typically, engineers would not be objecting, at least the right kind of engineers, people who take on a challenge and say, hey, I've never done this, but let me learn. Like, it's not wrong to feel afraid. Like, I also felt afraid when I started it. Hey, I've never done something, right? But
Mm-hmm.
after that, great engineers rise to the challenge.
Got it. Cool. Guys, I know you're watching us through YouTube, LinkedIn, Twitter. Post your questions. We have like a few seconds delay, so most likely, if you're typing something just right now, we'll receive that in a minute or like less than that. Um, Happy to answer, the questions you have, not myself, because I'm more from the business sides of things. I loved it when you showed when you showed how you can remove other people from the photos. Most likely everyone who goes to Rome would want to use your app just to remove the crowd. Cool. All righty. Maybe there's something else, Kartik, that I don't know you didn't share in the presentation, but some use cases or like some funny or super helpful, I don't know, some strange situations from your experience about the real-time programming, of course.
So I think it was a lot of fun. It really challenged me. And with Futurecam, because I was also the guy funding it, my bank account took a big hit. So there was the
Mhm.
pain. But as an engineer, I enjoyed the challenge because I had never done real time. In fact, I had never done image processing before this. I didn't have an academic background. I didn't have a professional background. So as an engineer, and many of us engineers build CRUD apps. So, it
Mhm.
was really exciting to challenge myself and, learn all of these techniques and, build myself up as an engineer so that whatever comes up next, I'm in a better position. And also there's a pride which I think all
Wow.
of us engineers can identify with, of attacking a hard problem and solving it.
Wow, that's what some of our customers here at Lemon, they say sometimes that they want to hire a developer, and sometimes they say I need an engineer, so someone who's really ready to dive deeper into something, learn new technologies, and in like engineer things, produce something new or work on harder tasks. That is super valuable for most of the teams and companies, of course. Okay, we have Abbas. You're the most active person here. I'm super happy you're also the part of the Lemon community, and you joined us. Abbas thanks us for organizing the session. Okay, how would
Okay, there's a question. I would say I am, but you have to ask the people who work with me. They have also told me I am. Yeah, I mean, I know that doesn't sound very modest, but yes, I would say so. Would it be right then to say that um, delivering an MVP is more important than the greatest? Yes. You want something real out there. May not be the best in the world. Otherwise, all you have are ideas if you don't have any app, even a prototype that people can play with. And a MVP de-risks the entire thing. Otherwise, who knows when it will be done? Will it be this month or this year or this decade? Right? When you have an MVP, you're moving forward, right? Imagine you're building anything like a car, let's say. If you have an initial prototype, it may not have a roof, it may not have a rear view mirror, it may not even have brakes in the very first version. If you're testing out a new kind of engine, let's say, right? Maybe you're testing a hydrogen powered car. But anything putting out there makes it real rather than ideas or theories. So, yes, I would agree. Thanks, Ola Wall, if I pronounced your name correctly.
yeah, I think so. Lovely. Yeah, that's the same question we have on screen. Um, that is, I think the entrepreneur or the founder part of yourself answered this question about the MVP. Many people, they have their ideas, but they take too much time to build until it functions perfectly. And then this idea might not be valid any longer, or someone has done something similar what you expected to do. So yeah.
Or you ran out of money building something perfect.
Yeah. We
Or
have
time.
we have a song of a Ukrainian band which says perfection is a lie. That's what you said, but in a shorter form. Cool. All right, guys. I think like for myself, I visited a couple of sessions from the Lemon IO series. I think for me personally, this one was the most technical. Perfection is enemy of good.
Yes,
Indeed.
very true.
I guess this session was the most technical, and that was either super new to most of the listeners, or super interesting, well structured, that they have no no more questions. Do you have any recommendation on what to read or listen, how to learn this topic?
I would say the best way to learn this, the answer is same as the best way to learn anything else. Do it.
By doing
Until then, it's all theory. Attack a problem.
okay.
Take
We
any
have,
real-time thing and attack it. You'll learn 10x more. And like I said, even if you don't do real-time further in your career, it'll really sharpen your mind as an engineer. So you'll be a better engineer after that.
love it. We had, I don't know if you, Kartik, answered this question before, but at the very beginning, we had someone asking if Node.js is good for real time. Do you
I
have
answered
what
it.
to add?
I answered
Oh,
it. I
you
would
did.
say no for two reasons. One is it's single threaded. The other is JavaScript is not the highest performing language. I would use a statically typed language, maybe Go, maybe even something lower level, maybe Rust, I don't know. So, yeah, so Node.js is perhaps not the best thing for real time. It's not that Node.js is bad, it's that Node.js is bad for real time.
Mm-hmm. Got it. Good. Gilberto, that's a very good question. If the workshop will be available to watch again later, I think so. All the previous workshops, I think they are stored on our YouTube channel. Was that too much of valuable information that people want to get back to this later
Yeah.
and review the details?
Appreciate that, Gilberto.
Good. We'll wait for a couple more questions. Java is the best. Okay. You're going to have some fights here. You can
Java
find
is
them.
the best. Okay, great.
Good. As we are waiting for more questions to come, I will ask not a non-technical question about your presentation. You've used a lot of Lemon branded pictures. Have you Googled them, or the Lemon team helped you make this wall like in a single brand style?
The lemon team helped me. And I do
Okay.
and I do like the lemon style, the lemony thing, and even your t-shirt is lemony, the
Oh
top
yeah.
of it.
Oh, you mentioned that. Okay.
Yeah, yeah.
Yeah.
So it's very fun style. So I was happy about that. And I love the
Lovely.
intro also with the city and the train going choo.
Yes. And it also goes smoothly, like in
Yes.
real time program.
True, true.
Good. I don't see any more questions coming in, so I don't want to waste anybody's time here, Kartik. I think we can share your information. Well, we actually did that on the Lemon AO events page. So people, if they have some questions after the session, I think it's okay for them to contact you in LinkedIn. If you
Sure.
have any suggestions for them, you can share the knowledge and some ideas even after the session.
Of course, LinkedIn, Twitter, whatever works. YouTube. In
Uh,
fact, the slides have a link to my website over here.
mhm.
This is where you'll find all the contact information, be it YouTube or whatever, LinkedIn, Twitter.
Awesome. Let us then choose the most interesting question. I see many questions were from like anonymous users, but still we can choose the best one.
I'll choose the one Olavo asked about the MVP.
Okay, cool.
And
I
MVP is
think
important for any application, all the more so here.
cool. Lemon team, could you please in the comments in the chat add the instructions or on what to do? You can there's Lemon AO page on LinkedIn, so we are always available. Olawala, please message us there so we have your contacts. We know where to ship the gift to make sure you got something after this event.
Will it be
Besides,
lemony, Kate?
would that be lemon kit? You
Would the
said?
gift be lemony?
I think so. I think so. Last time we had the branded hoodie with the logo, but that was sort of special edition. So we have some swag for the lemon team, and we have like extra with the limited edition with some other designs for the dev community. Yes.
Cool. It'll be on
Sometimes I
brand.
want to prepare more questions just to win this gift because I don't have that one.
Sure.
Good. Then Kartick, yeah, we'll contact. All right, cool. We found each other. Good. Kartick, thank you once again for the presentation you made, for the knowledge you shared, for the examples, a lot of visualization, especially with the um, power plant at the beginning of your presentation. I believe that everyone has come up with at least some new ideas. That's why I value every webinar that I attend, because this is time to concentrate and think on one topic and get out of the event with new ideas to implement after that. So that's super valuable.
I think we have one more question from Abbas. Shall
Yes.
we take that?
Yeah, for sure.
For some process, we can have pre-warm-up. How about IO part, as we need to empty buffer time? Yeah, so we don't do the IO part while pre-warming, which is to say, after we run the algorithms, we don't save the result to the disk. We just exercise the CPU, GPU, memory, and then throw it away. That is a warm-up. Because we don't really want the result. The user is also not expecting it. It's like when you warm up your car engine, your car is in neutral, right? It's not moving. So it's like that. Does that help, Abbas? Yes, and we do need to empty the buffers because we have fixed size buffers. So if we have 7 buffers, we'll use the first, second, third, all the way till the 7. Then we'll circle back and start again with the first one. Right, so when pre-warming, we don't save the buffers, we just override them. When actually running, when actually capturing, we save each buffer. And yes, the IO needs to be fast enough, the video compression needs to be fast enough, and on iOS it is. So as long as we are using the right APIs the right way, the IO will not be the bottleneck. And Kate, let's also give
Looks like
Abbas the swag.
okay. Abbas has, yeah, thanks from Abbas. So we have two gifts this time. Very good. The best question and the most active conversation. The
Yeah.
nominees. Lovely. Thank you again, Kartick, Abbas, Olawale, Gilberto, for asking all of the questions for the presentation. It was fun to have everyone here. I'm super thankful for Lemon AO to continue making this series of online events and connecting the engineers with the top CTOs and leaders in the tech industry. Let's see what other events we'll have in the next couple of weeks and months, and hopefully we'll see each other again.
Sounds
Enjoy
good.
the rest of your day, guys.
Thank you. Bye bye.